3.7, let's look at rational functions. Rational functions are ones that can be written as a function of two polynomials, such as f of x equal to p of x over q of x. If we look at our parent functions that are rational functions, you can see that f of x equal to 1 over x has these two curves here, and that they are moving in opposite directions. Then if you look at your second parent function over here of f(x) equal to 1 over x squared, you can see that it has two curves. And from its two curves, they are moving in the same directions. And so what we want to learn about this is where our certain characteristics are. You can see that it looks as though there's this imaginary line coming down between these two curves, as well between these two curves, and this is what we call a vertical asymptote. And so we want to look at our vertical asymptote, and we will say, as x approaches a, that f of x approaches either positive infinity or negative infinity. And so when does this happen? This happens when our denominator is equal to 0, when these denominators are equal to 0. And so what we say is that it gets really close but never touches. And so that's what we are looking for when we're looking at these vertical asymptotes. So let's look at this first example. It says find the vertical asymptotes of the function. So we're going to take this denominator here and we're going to set it equal to 0 and solve. So I get 2 minus x squared equal to 0. Now I'm going to go ahead and put that in standard form, and I'm going to move all these over here to this other side. So I have 0 equal to now positive x squared, positive x, negative 2. And by putting that in order and moving them to the right side, having my x squared positive, I could factor this quickly. This would be x and x, minus 1 and positive 2. And then I could solve it very quickly. So x minus 1 equals 0, so I get x to be 1, and x plus 2 equal to 0, x being negative 2. So this shows me that I would have vertical asymptotes at 1 and negative 2, because that's where my function would be divided by 0. Now when we begin to look at vertical asymptotes, we can't forget this idea of discontinuity or holes. Looking at this example here, it says find the vertical asymptotes of this function. Okay, no big deal. I'm going to take this bottom one here. I'm going to take x squared minus 4 equal to 0, and I'm going to solve it out. Now I'm going to have to factor that out, and that gives me an x plus 2 and x minus 2 by doing the differences of squares. And so if I take my original function, that would be x minus 2 all over x plus 2, x minus 2. And if I look at that rational function as a whole, you can see that x minus 2's would end up canceling, giving me a reduced function of 1 over x plus 2. And so what happens is I will have a vertical asymptote at x equals negative 2, the one that was left in the denominator, and this part here that cancels out, we call this a discontinuity at x equal to 2. So the one that you are canceling out is your discontinuity. The one that is left over is what's creating your vertical asymptote. You can see that here from my graph I have drawn. So I'm going to have a vertical asymptote here at x equals negative 2, the one that didn't cancel, and I have a hole here at 2 with the one that did cancel, or we call it discontinuity. So pretty interesting, just the way our functions are made up, we actually get characteristics from our graphs. If we talk about vertical asymptotes, we also need to talk about horizontal asymptotes, and we have 3 cases for that. Now horizontal asymptotes are this. They can cross, but not a domain restriction. And so let's look at case number 1. It says the degree of the denominator is greater than the degree of the numerator. If the degree of our denominator of our function is bigger than the degree of the numerator, here's what is happening. We are going to have a horizontal asymptote created. And that horizontal asymptote is going to be at y equal to 0. And so what you do is you can see if I look at the lead terms on the numerator, that's a 3x, and my lead term on my denominator in x squared, that reduces down to 3 over x, and that's why we are creating that asymptote at y equals 0. Case 2, if the degree of the denominator is less than the degree of the numerator, so you can see here the degree is 1, this is degree 2, what's going to happen is there's going to be no horizontal asymptote. And let's look at the function, see what's happening with that. If we look at 3x squared and we look at x, if I take 3x squared over x, that would reduce to just 3x over 1, so no problem in the denominator, no horizontal asymptote. The last case, if I take the degree of the denominator, we can see it to be 2, and the degree of the numerator, we can see it to be 2, and they are the same, then what's going to happen is the horizontal asymptote, I'm just going to abbreviate there, is the ratio of the leading coefficients. The ratio of the leading coefficients. And so my coefficients on this is 3 over 1. So that means I'm going to have a horizontal asymptote at y equals 3 over 1, or just 3. You can see that all of these answers are just y equal to a number, and the reason that is because y equal to a number is a horizontal line, thus my horizontal asymptotes. So to wrap up this chapter, let's put this all together and let's look at this example here. Find the intercepts in the horizontal and vertical asymptotes of the functions. So first thing we're going to do is we're going to find our intercepts. So I'm going to find my y-intercepts. In order to find my y-intercepts, I'm going to let x equal 0. So I'm going to plug in 0 over there. F of 0 is equal to 0 minus 2, 0 plus 3, all over 0 minus 1, 0 plus 2, and 0 minus 5. Cleaning that up, that gives me negative 6 over 10, so negative 3 over 5. And so there's my y-intercept. That would be at the value 0, negative 3 over 5. Then I want to find my x-intercepts. In order to find my x-intercepts, I'm going to set y equal to 0 and solve. So that would be 0 equal to x minus 2 times x plus 3, all over x minus 1, x plus 2, x minus 5. Now if I have a fraction equal to 0, then really all I'm going to do is set my top equal to 0, because that bottom's never going to be 0 and end up giving me a value of 0. So I'm just going to look at the top. Well, if I have that equal to 0, that means x minus 2 could be 0, so I get x to be 2, or x plus 3 could be 0, so x is equal to negative 3. And so now I have my x-intercepts. My x-intercepts would be at 2, 0, and negative 3, 0. Now let's add in, old news, let's add in our vertical or horizontal asymptotes. So my vertical asymptotes is going to be when we set our bottom equal to 0. That's where it could be undefined. So I'm going to take x minus 1, x plus 2, and x minus 5 equal to 0. Since it's already in this factored form, I have my 3 pieces. X minus 1 could be 0, so x could be 1. X plus 2 could be 0, so x is equal to negative 2. X minus 5 could be 0, so x is equal to 5. So that means I'm going to have vertical asymptotes at these 3 numbers. Where does our horizontal asymptotes occur? Well, we're going to look at the degree of the top over the degree of the bottom. Since I have 2 factors in the top here, if I were to multiply those out, I would end up with a degree of x squared. If I look at the bottom with having 3 factors here, that would be an x cubed. Therefore, since the degree of the bottom is bigger than the top, we would say that we have a horizontal asymptote at y equals 0. So look at all that algebra that we were able to accomplish. We're now able to see where it's crossing the x-axis, where it's crossing the y-axis, where asymptotes are occurring, and we're better able to see what this graph is doing. And so last example for the chapter, sketch a graph of f of x. So we're going to follow suit of what we just did, but now we're going to apply it. And so I'm going to do it the same order. First, we're going to find our y-intercept. So we're going to set x equal to 0. Setting x equal to 0, I get f of 0 equal to 0 plus 2, 0 minus 3, all over 0 plus 1 squared, 0 minus 2. So let's see, that gives me a negative 6 on top, a negative 2 on bottom, so 3. So I would have a y-intercept at 0, 3. Let's go into our x-intercepts. In order to find our x-intercepts, we would set y equal to 0. So I'm going to say 0 is equal to. Thus, we're going to be setting our top equal to 0. So that would be x plus 2, x minus 3. And so I'm going to solve that out, and I get x to be negative 2 and positive 3. So I'm going to have an intercept at negative 2 and positive 3. And then I'm going to look for my asymptotes. Excuse me. And so I'm going to say my vertical asymptote. Let's look at that. That's going to be when we set the bottom equal to 0. And so I'm going to say x plus 1 squared, x minus 2, I'm going to say it equal to 0 and solve. So x plus 1 equal to 0, that would be at x equal to negative 1. X minus 2 equal to 0, that would be at positive 2. So that means I'm going to have vertical asymptotes at negative 1. I'm hoping the color coding kind of helps you over here to see our math on the left, our graph on the right. And at 2, I'm going to have a vertical asymptote. Lastly, I'm going to look for my horizontal asymptotes. Now I'm going to look at the top. The top, if I multiply them together, would be an x squared. On bottom, it would be an x cubed. And so that means, like the one above, I would have a horizontal asymptote at y equals 0. So I'm going to draw that here. And so what is going on with this graph? This graph would actually look something like this. We've got this piece. It's going to come down like this. And then it's going to come like this. And so this means we knew that it was going up in this middle piece because there was no x-intercept between these asymptotes, and that's how I knew it created this form here. But that's really interesting that we can take the red, the blue, the pink, the light blue, put it all together and actually begin to see what are these graphs looking at. And this is all by just looking at intercepts, asymptotes, not just running to a graphing calculator. So I hope this helps you with this 3.7 section. Let me know if you need any more assistance.